Hi Esteban, and thanks for the question. In letter A, there are two things going on here. You have the product of x times the square root of x squared minus 4, and you have a composite function of x squared minus 4 and the square root of that. So what does that mean? It means we'll need both the product rule and the chain rule. Before we start anything though, I find it helpful to rewrite any of the square roots as exponents. So what that will give us is x times x squared minus 4 raised to the 1/2. Seeing that, the first thing we come to is the product of x times the square root. So let's use the product rule. And for us, let's call u x and the whole square root v. Using the formula, we have the derivative of u, which is just 1, because the derivative of x is 1, times v, which is simply rewriting x squared minus 4 to the 1/2, plus u, which in our case is x, times the derivative of v. But what about the derivative of v? This is where the chain rule comes in. And in layman's terms, the chain rule is the derivative of the outside times the derivative of the inside. Doing exactly that, we're going to get 1/2 times x squared minus 4 raised to the negative 1/2, because just like any other power, you bring what you have down and then subtract 1 from the original exponent. Now we need the derivative of the inside, which x squared minus 4, the derivative is simply 2x. And there you have it. Your hard work's done now. All you have to do is simplify. And simplifying, we get square root of x squared minus 4 plus the 2's cancel. It gives us x squared over the square root of x squared minus 4. Getting a common denominator of x squared minus 4 gives us the numerator of 2x squared minus 4. And there you have it. But before we go, let's take a look at letter B, because you're going to use a similar methodology here. The only difference is you're going to use the quotient rule. And remember, in the quotient rule, your numerator is u and your denominator is v. Thanks for the question. I can't wait to see the next one.